Okay, gang, I want to cover one last topic here from 2.4 called the intermediate value theorem. You should have seen this before, but if not, it's not a tough one to understand. So if f is a continuous function, okay, so again that means no holes, no gaps, no unboundedness in the middle. So if the function is continuous on a closed interval, and the output values on the closed interval of a and b are not equal, and k is any number between those outputs, then there are at least one number c such that if I plug that into f, that will give me that output. Alright, so here's the idea. If you have, let's say, a function that goes from, let's say, -1 to 8, -1 to 8, and we know it's continuous. Well, if it's continuous and it goes to -1 to 8, then it must have everything in between. It can even have some repeating values, but it at least has one of every number in between. So we would say that the intermediate value theorem guarantees us all the intermediate values. All right? So when you do this problem on the test, and I would have shown it in my little notes here, but it's, I don't know, as you can tell, it's not very legible. All right, so I want you to do the intermediate value theorem. Let me see if I can get this to work without the camera going too crazy. All right, so let's say I give you a function like f of x equals to x cubed plus 3x minus 2, and this is the interval, and I want you to show me that this function has a 0 on it. Do you know what a 0 means? That means that the y, the output, equals 0. That's what the word 0 means. And by the way, if this isn't clear, this is the interval. This is the x1 value to the x2 value. Now there's three things I want to see on the test. I don't care how fancy or not fancy you do this, but there's three specific parts that I'll grade you on. So the first thing I'm going to grade you on is you say that the function is continuous on the interval. So just in general, so you have a heads up, you may have a discontinuous function, but as long as it's continuous on the segment you're looking at, you're fine. You can apply this theorem. This is a polynomial, and they're continuous everywhere, so this in general has no discontinuities in it. But we're analyzing it in between this spot. All right, so that's the first thing you want to say, because the function has to be continuous on the interval to apply the intermediate value theorem. Alright, the second thing you want to do is you want to show what the output values are. Meaning, like, what is the height at f of 0? So at f of 0, I'm going to plug that into the function. Well, that's a minus 2 at the end there. Okay. Minus 2 brain. Brain and hand need to communicate here. Alright, so at 0, I'm at a height of -2. And I'm going to put in a height of 1. 1 plus 3 is 4, minus 2 is 2. Okay, so my heights go from -2 to 2. So whatever this looks like on this segment, my heights go from a height of -2, and whatever it's doing, I don't know what it's doing in the middle, to a height of 2. So since this is a continuous function on this interval, I know that I must have all the values. Okay, I might even have some repeating, but I must have all the heights between -2 and 2. So that's the third part that we want to say. Because I'm looking for a 0. Would we say that we have a 0 in between -2 and 2, right? We would. All right, so what you want to say is that since the function is below 0 and the function Okay, so what I'm saying here, since the height is below 0 and the height is above 0, right, 0 being what I'm looking for 0. So I'm saying I'm below that value that I'm looking for, and I'm above the value that I'm looking for. There must, this is a key part, and you have to have it. The intermediate value theorem, okay, you can shorthand it like I am on the test, it's fine. The intermediate value theorem guarantees that there must be a value C such that f of c equals to 0. All right, let me just say that one more time, but the key thing I'm looking for, I don't care how fancy you write this, I'm looking for intermediate value theorem in the third part, okay? So since I'm below what I'm looking for and above what I'm looking for, the intermediate value theorem guarantees that I must have what I'm looking for. Okay, that idea. There must be a value c such that f of c equals, and you could be even fancier, which it's more exact to say there must be at least one value of c such that f of c equals to 0, because you could have many places where this is true, right? All right, gang, that's it. I hope you enjoyed 2.4. I'll catch you down the road. Bye-bye.